Hi there. So I hope you're having a great day. Sorry I can't be there. Um, so the last week and a half, we've been talking about how statistics are gathered, how surveys are done, and other things. So we need to start talking about the actual statistics once we have them. So to do that, we're going to start today with a review of statistics, a review of some ideas from middle school and ninth grade: mean, median, mode, range, histograms, and box plots. So to start, I had the ages of 12 people at a movie theater. And so, some questions to consider. If we look at this data, what observations do we make, and can we make any inferences about the type of movie people or the people who are attending? So, you might look at this data and you might see the ages and think, there's children, there's some adults there. Um, what comes to mind for me is maybe this is a kids' movie. Maybe these are kids and their parents. So just considering a little bit of the context there and looking at those ages, maybe there's some thoughts to gather. So to look at this data, we're going to look at the measures of centers there. And a measure of center, just as a reminder, is a value that attempts to represent a typical value. So I'm going to put typical in quotations there because we know from our conversations that typical is not a really quantifiable thing, but we're talking about a typical value or representative value of a data set. And we try to do this by identifying the central position. There are several different kinds of measures of center, so we're going to review those today. They all have their strengths, they all have their weaknesses, and they're all just a little bit different. So knowing what they are and how they're different is important. So if you remember the mean from back in the day, how we gather the mean is we add all the data together, and then we divide by the number of data values. So if I were to give you a moment there to add all of those values up, we would get the sum of the data and then we would divide it by the number of values. And so adding those numbers up, we actually get 200. And as stated in the problem, or we could simply count, there are 12 data values. And so when we find that mean, we get 16.6 repeating, or 16 and 2/3. So if we think about what this means the typical age of the people at the movie is 16 and 8 months. Now, this mathematically, okay, is between 5 and 6 year olds and early 30s. But if there are no actual teenagers in our group here, it's hard to say whether this is truly typical. So another measure of center that we have is called the median. And the way I always remember median is it's kind of like middle, or the middle of the road there. So median is the middle value when the data is put in order from smallest to largest. So when we say middle value, we mean exactly in the centers. If we have an even number of data, great. If we have two numbers in the middle, then we take the average of those two values. Oops, average is AVE or AGE. Um, Again, average is another word for mean. I should have put that there. So you could pause here and scroll back up and rewrite those numbers in order. I'm just going to write them out here. So 4, 5, 5, 5, 6, 6, 7, 28, 30, 31, 34, and 39. Those are our 12 people in the movie theater. So there are 12 people. Some way that I've seen people do this to find their median value is they count, from the end. So count there, cross off there, cross off there. Other folks will just know if there's 12 values, then they go 6 on one side and 6 on the other. But either way, when we do this, we kind of get that 6 and 7 are in the middle there. So we're going to take the average of those two numbers and get 6.5. So this number is different than the mean, right? 6.5 is different than 16 and 2/3. And so again, this says the typical age is 6.5. Okay, well, we do have some people who are children's age, so perhaps that is more typical than 16 and 2/3. Again, it's hard to say given the limited amount of information we have, but it's something to consider. Mode is the value that appears the most frequently, excuse me. The value that appears most frequently. And I always remembered this, the mode is like the most, not the highest value, but the one that appears the most. So if we take a look back at our list that we made for the median, then we can see that the number 5 appears 3 times, which is more than any other number in our list. So 5 is our mode because it appears the most. So again, if we think about the typical age, okay, this is kind of close to 6.5. Not, perhaps there's some value in both of those measures of center when thinking about who is in this movie theater. The last one I want to talk about here, range, is not actually a measure of center because it doesn't tell us where the middle of the data is, but it gives us another kind of picture of the data. So range is defined as the difference between the largest and smallest values. So again, if we think about that computation, when we say difference, we mean subtraction. So we're going to take our largest value and we're going to subtract our smallest value. And then that gives us a number that represents the range. So for our data set, that would be 39 is the largest, 4 is the smallest, which gives us a range of 35. Now again, this doesn't really tell us a center of the data, but it tells us a limit of our data. It says that the ages of our people are within 35 years of one another. So we're going to be coming back to these measures of center and we're going to be using them. So if you need a reminder of how to do these, make sure you pause here and understand every part of your notes because like I said, we're going to use these as we continue forward. So moving ahead, frequency tables and histograms. This is a way to represent our data. So we can make lists of numbers just like we did in that earlier example, but that's not always very helpful. Sometimes a visual is a little bit more helpful. So a histogram is a kind of frequency table, and so we're going to use that to represent this data here. We have 15, or excuse me, we have different data values. We don't have any context here, but that's okay. So a frequency, remember, is a number of times that something occurs there. So this data is already written in order. If you're given data that's not written in order, it might be helpful to rewrite it. So the first thing we're going to do is look how many data values occur that have value between 150 and 155. Well, there's 2 values. So I'm going to write 2 for that frequency. I'm going to do that for every other interval here between 156 and 160. Well, there's 1 value. Okay, 1. 161 to 165. I've got 1, 2, 3, 4, 5 values that fit that criteria. So I'm going to do this for all of these other intervals. So count along with me and double check my work. But I believe if I've done this right, then I should get all of these following frequencies here. So now I'm going to make my actual visual here. So on the vertical axis will be my frequency of data occurring. So 1, 2, 3, 4, 5, 6. And on the horizontal axis, I'm actually going to list my intervals here. So 150 to 155. I'm not going to label this exactly like a coordinate graph because I'm not, measuring this out, representing it kind of like a ruler, but I'm actually stating what the boxes are, what the intervals are. So a little bit different here. 166 to 170, 171 to 175, 176 to 180. Oh, and then 181 to 185. So really, the hardest part of the histogram is actually just setting it up, because now that we've got our frequency table, we're just going to translate these frequencies into bars on our histogram. So the interval 150 to 155 has a frequency of 2. So I'm going to make my bar 2 units tall. For the next interval, it only has a frequency of 1. My next interval has a frequency of 5. Notice that my bars are exactly side to side. They're right adjacent to one another because my intervals are adjacent to one another. We're not doing little gapped bar graphs here, a histogram. They are all snug up next to one another. So I finished my histogram. I've got my frequency table translated into this bar graph here. And again, what this is just giving me is it's giving me a visual here. I can see, oh, in the middle here, these middle intervals, there's, more things happening there than there are on the ends. So in the future, when we look at some other kinds of representations, histograms are going to be a good background bit of information, a good reference for us. Besides making histograms, we can also use histograms. We can interpret these. So the histogram below shows data about scores on an algebra test. So we've got the score of the student on the horizontal axis, we've got those intervals written, and then we've got the number of students who have that score there. So the question, how many total students took the test? Well, okay, I can add up, or I can count the frequency of each interval, knowing that my intervals don't overlap, right? So then I can add those up, 2 plus 5 plus 8 plus 12 plus 16, or plus 6, excuse me, a little bit different there, plus 6. And when I carefully add those up, I get 33 students. So the histogram shows me how many students took the test, and then question B, how many students scored at least a 71 on the test? Okay, so at least a 71 would be something 71 or more. So I can look, well, 71 to 80, and then all these other intervals also count. So I'm going to count my 8, my 12, and my 6 because they all fit that criteria. And 8 plus 12 plus 6 gives me 26 students who scored a 71 or more. And then this last question, can you determine the highest grade from the histogram? Well, according to our histogram, the highest interval is 91 to 100. Okay, most tests are scored out of 100%. But this doesn't tell us whether those 6 scores were, 6 100s or 6 91s or 91, 92, 93, 94. It doesn't tell us anything like that. So unfortunately, no, we can't determine the highest grade. We can only see, the number of students in the highest interval, not their individual scores. not their individual scores. So that's not to say that we don't have a good picture of this test, right? If we were translating these into letter grades, okay, B's are B's, A's are A's. Perhaps that's just how we want to break it down. But if we were asking about the actual highest grade, unfortunately, we just don't have that information. So frequency tables and histograms have several benefits. Obviously, the big one is that it allows us to visualize our data, And going off of there, we can see some general trends. And that's important because when our data is just spread out randomly on a list, it's hard to see those trends and actually make sense of them sometimes. Unfortunately, histograms and frequency tables do have some shortcomings, right? We can't tell any exact values. Which means that we can't actually measure or calculate measures of center. If I asked you to find the mean or the median of the mode, you can't even calculate the range. It doesn't give us the level of precision that we could potentially need. So histograms and frequency tables are really useful, and we are going to be using them, but we do just want to keep in mind that there are some shortcomings there. They are obviously not perfect. We're going to look at one more type of visualization. This one's called a box plot. You might remember it from earlier years as a box and whisker plot because of the shape of it. So box plot is another visual representation of data that shows a distribution of data using a set of quartiles rather than detailed values. So when we say quartiles, that means that our graph is broken up into 4 different sections. And when we say quartile, we mean a fourth. Each section represents 25% of the data. So this is allowing us to see how our data is spread out and how it's related. Little pro tip here, Ms. Womble, pro tip is we should always start by ordering from smallest to largest. Oops, double exclamation point. It's that important. Just like when we calculate our median, going from smallest to largest is just going to make our lives easier. Part of the reason is that we actually do calculate the median. So for example 1, I've got a list of 15 data points here. And so looking at this list, the 5-number summary, those are the 5 numbers that we're going to calculate every time we make a box plot. So a couple of those are familiar. The minimum, right? We look at the smallest number. So we have a 3 there as our minimum. Our maximum is the largest value, so 25. And then our median is the middle of our data. So if we have 15 points, we're going to have 7 points and 1 in the middle. 1, 2, 3, 4, 5, 6, 7. And let me just double check. 1, 2, 3, 4, 5, 6, 7. All right, so this 7 is our median here. And then we're going to find the lower quartile and the upper quartile. And if you remember from Algebra 1, the lower quartile and the upper quartile are like the medians of the two halves. So the lower quartile is the median of the lower half. So we have 7 numbers in the lower half. So our lower quartile is going to be 5. You might also hear this called the first quartile. Those are used interchangeably there. And then our upper quartile is the median of the upper half, which in this case is 17. And you might also hear that called the third quartile. The median would be the second quartile because it's the second one that happens. So if you need to take a moment to pause here and go through the steps of actually finding the median and then the two quartiles, just for your own practice there, please do so. Otherwise, so the 5-number summary allows us to make then our box plot. So I use a number line here, and I'm going to mark first my minimum and my maximum with little points. So my minimum and my maximum, I'm going to mark that at 3 and at 25. And then I need to mark my lower quartile, my median, and my upper quartile. I'm using these little vertical segments here because those segments are going to form my box. And then reaching out to the minimum and maximum are going to be two little whiskers. So this gives us a representation. It kind of tells us that here's our median. These sides and the dots in the middle mark will always represent the same values. So we have our median at 7, and knowing that each one of these represents 25% of the data, 25%, 25% of the data, 25% of the data, that tells us that we have more values kind of put in this 3 to 7, or excuse me, we don't have more values because if it's 25%, they're exactly the same number of values in each segment. But the smaller a section is means that there are more values closer together. Whereas in some of these other quartiles, there are the same number of values, but they're more spread out. The interquartile range is just one more thing to consider here. The interquartile range tells us the range between our lower and upper quartiles. So it's not from the absolute minimum to the absolute maximum, it's just those two quartiles. You might think of it as the middle 50%, right? Because it's between those two quartiles. So how we do this is we take the upper quartile and we subtract the lower quartile, and then we get our interquartile range. So for us, by our measurements, that will be 17 minus 5 equals 12. So our range here would be 22, right? That would be all of our data is within, 22 units of one another. The interquartile range tells us that the middle 50% of our data is within 12 units of one another. Now, again, without a context, that may not be very meaningful, but right now we're just practicing this skill. So right now, I want you to do example 2 on your own. So pause the video, and once you think you've got a box plot for these data points, go ahead and press play, and we will double check. I know that there's an issue between 10 and 25 on the actual scale there. Just do your best. So pause here and make your box and whisker plot using those 5-number summary and find the interquartile range. All right, so let's just double check. We need to find our minimum, our lower quartile, our median, our upper quartile, and our maximum. So since this was already in order for us, we've got our minimum 18 and our maximum 94. Our median is our middle number. Now, however you did this, you probably found that there were 2 numbers in the middle. So again, we take the average of those, 55 and 50. The average is 52.5. And then our lower quartile, and there's always a question here when we have this split, we actually include those kind of middle terms as a part of our upper and lower half. So that may change your answer here, but you should have gotten a lower quartile of 40 and an upper quartile of 77.5. So once we plot those points, 18 is going to be somewhere in there, and then 94, and then 40, 52.5, and 77.5. Allows us to make our box 52.5. And then the very last thing, if you did calculate your interquartile range, hopefully you took 77.5, subtracted 40, and got 37.5. So when I come back, we're gonna be talking about why or practicing using these some more in some context. But tomorrow I'm gonna ask you to think about some representations to lead us into our next topic. So go ahead and begin your practice. If you have any questions, be sure to email me or check with your neighbor. You've got lots of great people around you. Have a wonderful rest of your day.